All right, moving on to 22. What product isotope is formed by decay of radon 222? All right, so you use this figure. So we have radon, which I believe is Rn. So this is 222 Rn. If you look on a periodic table, Rn, I believe is 86. 86. So this is undergoing decay. So it says here that radon undergoes alpha decay. So we would write 4 over 2. I like using the fish symbol, alpha, plus some other element. 222 minus 4 gives us 218 up here at the top. 86 minus 2 gives us 84. All we have to do is look up number 84 on the periodic table, and that corresponds to polonium. And that's how that problem is done right there. All right, moving on to the next problem. Assuming you have a 100-gram sample of iodine, what product isotope is formed? There's two questions here. They want you to figure out how much is left after a certain amount of time, and they also want to figure out the product isotope. All right, the product isotope, this is the decay particle. This would be our product isotope. So let's take a look at this one. This one would look something like this, 131 iodine. Iodine's atomic number 53. And it says up here that it does decay. Iodine 131 decays by beta decay. So we'll write 0 minus 1 with our beta. So the top number stays the same of 131. So the bottom number becomes 54 because 54 and negative 1 gives us 53. So that the numbers are equal on the bottom. 54 corresponds, looking on the periodic table, to xenon. All right, so now we move on to the half-life problem. So we start off with 100 grams, NO is equal to 100 grams. And we're looking for N, this is our X. It gives us a time of 24.21 days. And if you look on the chart up there, they were nice enough up here to give you the half-life for iodine of 8.07 days. So dividing these two gives me 3 half-lives is equal to N. So now I can plug into my equation. N is equal to 100, 1/2 raised to the 3rd power. If you do that, that would be, taking out my calculator here, that would be 1/2 raised to the 3rd power. Gives me that, which is 1/8 times 100. Gives me this number, 12.5. So I have 12.5 grams. All right, that's number 23. On to the last and most challenging problem. How much nitrogen-14 remains from a 200-gram sample of carbon-14 after 17,000 years? So it looks like this. First things first, you would write our equation here. Carbon-14 decays by beta decay, 0 minus 1 electron, 14, 7 nitrogen. Now moving on to the half-life problem. This one takes a slight twist. You're looking for N. N is going to be our X. The original amount is equal to 200 grams. Time expired is 17,190. The half-life, which if you look on the chart again, is given as 5,730 years. All right. So now we can figure this out, that N is equal to 200, 1/2 to the N. We can solve N because N is equal to 17,190 divided by 5,730 gives us a total of 3 half-lives. So once again, this is 1/8, 1/2 raised to the 3rd power times 200. All right, doing that in our calculator. So basically 1/2 is, 1/8 times 200. So it gives me 25 grams. But 25 grams of carbon are left over. This means that there's 175 grams of nitrogen being produced. That's it. Good luck. Study well. Tomorrow's the test. I hope this helped.